Welcome to this video about LSTMs. In this short video, we'll break down what an LSTM network is, why it was created, and how it solves key problems in processing sequential data like language, speech, and time series. We'll start with the basics of LSTMs, explore how the gates can control information flow, and then look at where they're used in real-world AI systems. LSTMs stands for Long Short-Term Memory, a type of recurrent neural network, or RNN, designed to remember information over long sequences. Standard RNNs often forget earlier inputs, but LSTMs solve that by adding a special internal memory, called the cell state, that carries important information forward through time. Traditional RNNs struggle with two key issues: vanishing and exploding gradients. When training on long sequences, gradients can either shrink to zero or grow uncontrollably, making it nearly impossible for the model to learn long-term relationships. LSTMs overcome this with controlled information flow, letting the gradients pass smoothly through time without breaking. The forget gate decides what information to erase from memory. It looks at the previous hidden state and the current input, runs them through a sigmoid function, and outputs values between 0 and 1. It decides which information to keep and which to forget. Next comes the input gate, which decides what new information to add. It filters inputs through another sigmoid and tanh function to create new candidate values, and then it updates the cell state. Together, the input and forget gates balance old and new information, giving the network precise control over what it remembers. Finally, the output gate determines what part of the cell's memory to reveal as the output. It filters and scales the cell state to generate the hidden state, which both serves as the model's prediction and passes information to the next LSTM cell. This keeps context alive over time. LSTMs have transformed many AI applications. In natural language processing, they're behind machine translation, sentiment analysis, and text summarization. This helps models understand meaning and flow across sentences. In time series forecasting, LSTMs predict stock prices, weather, or even energy demand by learning long term patterns. Their ability to remember what matters most makes them far more effective than older models for any sequence based task. In short, LSTMs are powerful memory networks that have solved one of deep learning's biggest problems: how to make machines truly understand context over time. They paved the way for even more advanced architectures like GRUs and transformers, which continue building on the idea of long term memory in AI. Thank you for watching this video.